Hello, this is Melanie Looper again in Professor Fox's Chem 1405-6440 online chem class. This is lab number 5, I believe, balancing chemical equations. I have all my material set up right here, all my atoms set out, and I will get started balancing some equations. With a wet erase marker, write the 5 colors of the model pieces in the color column of the tally table on the balancing equations mat. Okay, so we have red, blue, green, yellow, and white. Okay, still using the wet erase marker. Write the symbols and formulas for the reactants and products of the first equation on the balancing, from the lab questions on the balancing equations mat. Write on the lines above the 4 boxes, not in the boxes. Leave the lines labeled coefficient blank at this time. Okay, so first one we have HCl plus NaOH yields NaCl plus H2O. Assign a different color to each atom in the equation in the symbol column of the tally table. Write the symbol for the atom beside the assigned color. Use the red pieces to represent oxygen and white to represent hydrogen. So yes, we do have both of those. So red, oxygen, white, hydrogen. And then we have Na and Cl. So let's do Na as blue and then Cl as, let's do green. Group the molecules according to the equation based on the colors that were assigned to the atoms in the appropriate squares on the mat. Look only at the number of atoms present in each molecule. For this activity, the shape and arrangement do not matter. Count the atoms of each color on both sides of the equation in the tally table. Record the number. Okay, so we have on this side 2 hydrogens, which are white. We have 1 Cl, which is green. Have an oxygen, which is red, and an Na, which is blue. Then on the other side, we have an Na, a Cl, and 2 hydrogens. Oops. 2 hydrogens and an oxygen. Cool. Count the atoms of each color on both sides of the equation. The tally table, record the number of atoms of each color on the left side and the right side of the equation. So we have 1 oxygen on the left side and 1 oxygen on the right side. We have 1 Na on the left side and 1 Na on the right side. We have 1 Cl on the left side and 1 Cl on the right side. And we have 2 hydrogens on the left side and 2 hydrogens on the right side. So cool, that is balanced. If each element has an equal number of atoms on the left and the right side, the equation is balanced. If the equation is balanced, go to step 8. Start the balancing process with the atoms that appear in only 1 molecule on each side of the equation. Remember, only adjust the number of molecules. Coefficients molecules cannot be broken apart. Once the equation is balanced, write the total number of molecules in each box on the line above the box labeled coefficient. Once the equation is balanced, write the total number of molecules in each box on the line above the box labeled coefficient. Take a photograph of the balancing equation map with the equation properly balanced and the model pieces in their appropriate groupings. Disassemble the molecular molecules, separate the pieces into groups again by color. Erase all information from the mat with the exception of the colors of the model pieces. Repeat the process with the next equation on your equation sheet. So there's one molecule here, one molecule here, one here, and one here. So that one is balanced, easy peasy. Take a picture of it. I'm assuming put these on the lab report. So yeah, now time to move on to the next one. I'll finish these out and write this lab report.